Welcome back. From the past few sessions, we have been learning about the data transfer group of instructions. And if you have noticed, we have been learning about two instruction types in every session. Breaking that pattern, in this session, we are going to learn about the instruction types LDA a16, STA a16, and XCHG. So without any further ado, let's get to learning. Coming to the topics that we are going to cover in this session. At first, today we will learn about the instruction type LDA a16. Thereafter, we will learn about the instruction type STA a16. And finally, we will learn about the instruction type XCHG. So let's begin with the first instruction type, that is LDA a16. Now coming to the instruction type LDA a16, we actually have used this instruction at quite a few instances. Today, we are going to decode this instruction in details. Now, before we do that, let's understand why do we exactly need this. And for that, I would like to take you to the previous session. In the previous session, if you remember, we learnt about the instruction type LXI-RP, D16. Now we used this instruction so that while storing the program in the memory, we could reduce some space. If you remember, in order to store the first instruction, it required 3 bytes, and thereafter when we performed MOVA, M, that is, we were loading the accumulator with the value inside that particular memory location, this particular instruction took 1 more byte. Altogether, the entire operation took 4 bytes of memory space. Now notice, we were providing the address ourselves, and thereafter we were instructing the microprocessor to move the content inside the accumulator register from that particular memory location. Instruction-wise, we used 2 instructions, and in the memory, we occupied 4 bytes in order to store these 2 instructions. Now you think about it. What was the job? Considering this entire program, the job was to load the accumulator with the content within this particular memory location. And for that, we involved the HL register pair, then we loaded the address on that, and finally using this instruction, we moved the content from that particular memory location inside the accumulator. Now, could we do that without involving all these? That is, 2 more registers or a register pair and essentially 2 different instructions? Well, it looks like we can. In that, the LDA a16 comes at rescue. Now, within the instruction, the mnemonic LDA stands for Load Accumulator Contents from Memory. Now, we know within the memory, there are 64K different locations, and in order to access all of the locations, the microprocessor has the address bus. Let's now decode the LDA a16 instruction. Now we already know the meaning of LDA is Load Accumulator Contents from Memory. Now what is this A16? Well, this specifies all the different addresses which are of 16 bits. So as you can see, instead of involving the HL register pair, using this particular instruction, we can directly send the address within the instruction to the microprocessor. So can you figure out in which category lengthwise this instruction will fall in? Think about it. LDA is going to occupy 8 bits of space, and within the instruction itself, we are sending 16 bits address, so 16 bits. So cumulatively, the entire instruction will fall under the category of 3-byte long instructions. Now let me illustrate how this will help us. Say within the memory location F821, we have the hexadecimal content EA, and you already know this notation, which is in hexadecimal, is used for the ease of human readability, not in reality. Within the memory location, this data is going to be stored as binary. Anyway, we would like to load this inside the accumulator. And for that, if we execute the instruction LDA f821, since we are sending the address directly to the microprocessor through the instruction, using this address, the microprocessor will be able to directly point to the memory location. And once this instruction is executed, the contents within the memory location will be loaded to the accumulator register. Interesting, isn't it? We didn't have to involve the HL register pair, and we did all the work using only a single instruction. And in doing so, we also saved the memory space for storing this. If you remember, in the previous example where we used LXI RP D16 instruction, along with that when we used MOV A, M, both the instructions within the memory occupied 4 bytes of space, whereas this entire instruction will save 1 more byte, and using 3 bytes we can perform the same. So remember, the instruction type LDA a16 is a 3-byte long instruction, and here the LDA stands for load accumulator contents from memory. Now, from which memory location? The memory location will be sent directly in the instruction itself. So that was all about the instruction type LDA a16. Let's now learn about the instruction type STA a16. Now coming to this instruction type, we also have used this in quite a few instances, haven't we? So let's decode this. In this instruction, the mnemonic STA stands for Store Accumulator Contents in Memory. So clearly, this is the reverse of the previous instruction. Now if we consider the memory, we already know all the addresses are of 16 bits. Therefore, from the instruction STA a16, the a16 refers to the 16-bit addresses of the memory. And just like the previous instruction type, here also STA is going to occupy 8 bits of memory space and a16 is going to occupy 16 bits of memory space. So this instruction too falls under the 3-byte long instructions category. Now let me explain the functionality using an example. Say within the accumulator register, we have got the value AF. And our intention is to store the value in the location F821. And for this, if the microprocessor just executes the instruction STA F821, since we are sending the address directly to the microprocessor through the instruction, using this address portion, the microprocessor will be able to point directly to the location in the memory. And once the entire instruction is executed, the content of the accumulator, that is AF, is going to be stored in that particular memory location. So remember, STA a16 stores the content of the accumulator within the memory location specified by the a16 part. Also, this is a 3-byte long instruction just like LDA a16. Now another thing to note in here, we only have the instructions like LDA a16 and STA a16. There are no instructions like LDB or LDC. Neither there are instructions like STB or STC. Remember, both LDA and STA refers to the accumulator register only. And this is the reason why accumulator is a special purpose register. Unlike the general purpose registers, accumulator can be addressed in multiple ways. So that was all about the instruction type STA a16. Let's now learn about the instruction type XCHG. Now coming to the instruction type XCHG, you might be wondering, we haven't mentioned any register, neither we have mentioned any address or data within this instruction. So what does it do? Well, it stands for exchange the contents of HL pair with DE pair. Remember, it will only work between these two register pairs. Neither it is going to work with BC and DE, nor it is going to work with BC and HL. Only DE and HL. Now let me explain how it will work using an example. So basically, we will load some data inside the DE pair and in the HL pair as well. And thereafter, we will execute this instruction to see what happens. So using the instruction LXI RP D16, we will load some data in both of these register pairs. So at first, let's execute the instruction LXI D, ABCDH. Now once the microprocessor executes this instruction, within the D pair, the data that is ABCD will be loaded. So let's assume the instruction has been already executed. So within the D register pair, we will have this value now. Now coming to the next instruction, the instruction LXIH, 1234H will be executed by the microprocessor, and if it is executed, within the HL register pair, the value 1234 will be loaded. Now what do we want to do? We actually want to see what happens if the XCHG instruction is executed. So let's have that now. Now once the microprocessor executes this, notice what will happen inside the register pairs. Did you see what happened? The contents of the HL register pair got exchanged with the contents of the D register pair. Now the instruction XCHG falls under the category of 1 byte long instruction. Now let me tell you why this instruction is a very useful instruction. Think about it. If we didn't have this instruction, in that case, if we wanted to exchange the contents of these two register pairs, how we would have done it? We would have selected one more register where we could store the data from one register at first, making space for the data from the another register to come to that place. And once that moving was done, thereafter, from the register which we are using as a temporary storage, we could bring that data into the previous register. And the same thing would have been performed for the remaining part of the register pair as well. Think about it. How many instructions did we need in that case? And how long memory storage space would have been wasted? Instead, having XCHG is actually saving us from all those hassles using only a 1 byte long space. So clearly, this is one of the very interesting instruction type that the 8085 microprocessor has. So that's all about the XCHG instruction type. Remember, it will only work with the HL pair and the DE pair. So in this session, we covered the topics: instruction type LDA a16, instruction type STA a16. These two instructions are of 3 bytes long and they are specific to the accumulator register. Finally, we learned about the instruction type XCHG. This is an instruction which falls under the 1 byte long category, and it only works with the HL and the D register pairs. Alright people, that will be all for this session. In the next session, we are going to learn something called the